Hello guys, in this lecture, let's try to quickly understand about the selection sort. Okay, so it is somewhat similar to the bubble sort. So if you haven't watched the bubble sort video, then please go watch it out because while implementing the selection sort, we are going to pick some of the snippets from the bubble sort code. Okay, like swapping code, we are obviously going to take from the bubble sort code. Okay, so if you have not watched it, then please go watch it or at least get the snippet from that video, right? So now let's try to understand what is selection sort. Okay, so let me quickly zoom it a little bit so you guys can see. Let's see the definition first. Okay, so it is a simple sorting algorithm that works by repeatedly finding the minimum element from the unsorted part of the array and swapping it with the element at the beginning of the unsorted part. Okay, so it is similar to bubble sort, but instead of placing the large number to its sorted position, it places the small number to its sorted position. Okay, so what does this definition mean? Okay, so let's discuss about bubble sort a little bit. Okay, let's quickly discuss about it. Okay, so what happens in bubble sort? We have an unsorted array. Okay, so what happens? We check two numbers, whichever number is whichever order is not correct, we swap those positions of those numbers, right? And this way we like shift the larger number at the end of the array. Okay, we collect all the larger numbers at the end of the array, right? So this way we move the larger numbers to their sorted position. Okay, now if I talk about the selection sort, so what happens in selection sort is we try to find the minimum number and we try to move it to its sorted position. Okay, so let's say we have this array, right? Okay, so what we will do, we will start with the first index and then we will compare it with the second index. Okay, so our current element here, it's zoomed enough, right? So our current element here will be 7. Okay, and then since after comparing these two, the minimum is 4, right? In 7 and 4, 4 is minimum, right? So we will store it in some variable or something. We call like 4 is the current minimum. Okay, and then we move to the next iteration. We find, see, now we try to compare 2 with the 7. Since 2 is the minimum, right? 2 is smaller than 4, right? So it will be our new minimum. So instead of 4, we will update here 2. Okay, now we'll again move on to the next iterations. Here we have 9, which is greater than 2. So we'll move on. Here we have 3, which is greater than 2. So our minimum will be still 2. So now what we will do, next step, we simply swap the position of the current element and the minimum. Okay, okay, I think I haven't copied it. So something like this, let me show you. Here we will place 2 and then here we will place 7. Okay, now we will move on to the next number. Okay, so now our current number, let me quickly add it here. Okay, after swapping it, now our current number will be this, right? This 4, because this is already sorted now, so we won't consider it anymore because this is already in its sorted position. So our current number will be 4, right? Now from here we will try to check for the rest of the numbers. So 7, which is greater than 4, so still our minimum will be 4. Okay, now we'll go to 9. 9 is also greater than 4, so minimum will be 4. And now 3. So 3 is also greater than 4, so our new minimum will be 3, right? So this way what will happen? We will simply swap the position of 4 and 3. Here we will add 3 and here we will add 4. Okay, so this way we keep on moving the smaller numbers to their sorted position. Okay, so I hope I made it somewhat clear for you guys, like how the sorting like selection sort works, right? So now let's try to understand it with the help of visual go, right? I struggle like taking its name. It's a little bit confusing, even though it's highlighted like it's visual go. Okay, we'll call it visual go from now onwards, right? So here we have an unsorted array, as you can see, and here I have selected the selection sort already, right? So let's now play it in a little bit faster pace. Now let's play it. Okay, I think from here only we have to play or sort. Okay, so see, it's going too fast, guys, right? See, it took the first element and then it tries to check whichever element is the minimum of this one. Okay, so let me quickly close this, and I think here it will be fine, right? Because otherwise it is overlapping these numbers. Okay, let me quickly zoom out. Yeah, that will be fine. Okay, so now here we have the starting number which we are taking as current number, and then we are trying to find the minimum number which is smaller than 5. Okay, see, 6 is not smaller than 5, then it went to 35, 31. 5 is also not smaller than 5, then 11, 17. Now let's see. Okay, so 4 is our new minimum right now since it is smaller than 5. Okay, now we won't stop here, we will still search for the new minimum. Okay, in case if we find some other element which is smaller than 4. Okay, see, it is keep on checking it, and now it found like there is no other element which is smaller than 4, so it is our new minimum and this is our current element. So what will happen, it will swap their places. Now 4 will be at the position of 5 and 5 will be at the position of 4. Just see, it got swapped, right? Now 4 is semantic here, so 4 is sorted already, so we will not consider 4 anymore. Okay, or we can say in simple words, we will shrink the window of our sorting algorithm in every iteration, because every time we are sorting something and we are placing it in its sorted position, right, at the beginning, so we will not consider it anymore. So now the iteration will start from 6. Okay, so let's play it. See, now 6 is our current element, and now it will try to find the minimum element. So now it found like 5 is the minimum, 5 is smaller than 6, so it will consider this as a new minimum, and now it will keep on trying to find like is there any other element which is smaller than 5. Okay, then we will update that number as the minimum. Okay, so let's play it. See, it is still trying to find the new minimum. So now what happened, it found like 4 is smaller than 5, right? So it updated 4 as the new minimum. So it is the smallest element which we found after we found the minimum, right? So this is our new minimum and this is our current element. So what will happen, we will simply swap their places, right? So okay, so this way, as you have noticed, like now it is not considering these two elements, and the color also have changed for these two elements, right? So what will happen, it will start from this particular number and then it will keep on iterating it. Okay, so let me quickly fast forward it a little bit so you guys can see everything, because I don't want to bore you guys by playing it in a slow pace. Okay, so if you see, just have a close look like how it is sorting. Okay, so it is finding a number. Okay, it is going out of control, right? So it is finding a number and then it is finding a new minimum and then it is swapping it, and whichever number is swapped or whichever number is sorted, it is not touching that number again. Okay, otherwise what will happen, we will run into infinite loop, right? So let's say we have swapped 4 in its sorted position, right? So if we again consider 4, then there will be no other elements which is smaller than 4, right? So it will keep on looping, right? And we don't want that, right? So see, now I think all the elements are sorted, that's why our list color is changed. Okay, so after all iterations, the last element will naturally be sorted. So what it is saying, like if all the elements are sorted, then obviously the last element in the array will be sorted, right? So that's a general thing, right? So this is how like the selection sort works. Okay, so it is somewhat similar to like a bubble sort. Okay, so I hope like I made it clear for you guys like how selection sort works, what is selection sort. So yeah, this is it for today's video. Now in the next video, let's quickly implement selection sort. Okay, so yeah, see you in the next one.